The natural world is full of wonders, from towering trees to the smallest insects, but within this beautiful tapestry of life, there are also hidden dangers. Some of the most powerful and deadly substances known to humanity are not made in a lab, they are created by living things. These natural toxins are produced by bacteria, plants and fungi for various reasons, such as defense against predators or to compete with other organisms. They are fascinating from a scientific standpoint because they are incredibly complex molecules that can have dramatic effects on the body, even in microscopic amounts. Understanding these poisons is not about being afraid of nature, but about respecting its power and complexity. This journey will take us through the world of some of nature's most formidable creations. We will explore 5 of the deadliest toxins found on Earth, learning where they come from and what makes them so dangerous. These substances have played roles in history, from accidental poisonings to deliberate acts of malice, and they continue to be a subject of intense scientific study. By looking at how these poisons work, we can learn a lot about our own biology and the intricate machinery that keeps us alive. It's a reminder that even the most seemingly harmless plant or microscopic bacterium can hold secrets of life and death. The 5 toxins we will be looking at are botulinum toxin, ricin, amatoxins, strychnine, and cyanide. Each one has a unique story and a different way of interacting with the human body. Some act with frightening speed, while others are slow and insidious, causing damage over days. Their lethality is measured in incredibly small quantities, highlighting the precision with which they have evolved. This exploration is not just a catalog of dangers, but a testament to the incredible power of biochemistry and the ongoing dance between life forms on our planet. It's a field where a single molecule can be the difference between life and death. So, let's dive into the microscopic world of these potent poisons. We'll start with the undisputed champion of lethality, a substance so powerful that a minuscule amount is enough to cause widespread harm. Then, we will move through poisons found in common plants and seemingly innocent mushrooms, uncovering the stories behind their fearsome reputations. This knowledge is not meant to scare you away from a walk in the woods, but to arm you with awareness. Understanding the world around us, including its risks, is the first step toward navigating it safely, and with a deeper appreciation for its complexity. When we talk about deadly, nothing else comes close to botulinum toxin. This substance holds the title of the most lethal poison known to science, whether natural or man-made. It is produced by a bacterium called Clostridium botulinum, which is surprisingly common and can be found in soil and water all over the world. The bacteria themselves are not the problem. The danger arises when their spores, which are like tiny dormant seeds, find themselves in a low-oxygen environment. In these conditions they germinate and begin producing a suite of toxins, 4 of which are incredibly harmful to humans. The sheer potency is hard to comprehend. Just how deadly is it? The lethality of a toxin is often measured by something called the LD50, which is the dose required to be fatal for 50% of a test population. For botulinum toxin, the LD50 is about 1 nanogram per kilogram of body weight. To put that into perspective, a single crystal, the size of a grain of sand, could theoretically kill nearly 10,000 people. This makes it millions of times more deadly than something like cyanide. Most cases of exposure in the United States, typically between 10 and 30 per year, come from improperly canned foods where the spores have survived the heating process and found the perfect oxygen-free environment to thrive. The way botulinum toxin works is by attacking the nervous system. It is a neurotoxin, which means it interferes with the signals that travel between your nerves and your muscles. Specifically, it blocks the release of a chemical called acetylcholine, a neurotransmitter that tells your muscles to contract. Without this signal, your muscles become paralyzed. This paralysis starts in the face and spreads downwards. If left untreated with an antitoxin, the paralysis eventually reaches the respiratory muscles, including the diaphragm. This leads to death by asphyxiation, as the victim is no longer able to breathe. It's a chillingly effective mechanism. Despite its terrifying reputation, botulinum toxin has found a surprising use in medicine. You might know it by its commercial name, Botox. In extremely tiny, controlled doses, the toxin's muscle-paralyzing effect is used to smooth wrinkles, treat chronic migraines, and manage conditions involving muscle spasms. This is a perfect example of how the same substance can be a deadly poison or a helpful medicine. It all comes down to the dose. Another interesting fact is that infants under 1 year old should never eat honey, because it can contain Clostridium botulinum spores, and their developing immune systems can't fight them off before they produce the toxin. Next on our list is ricin, a deadly protein found in the beans of the castor plant, Ricinus communis. This plant is grown worldwide for castor oil, a useful product with many industrial and medicinal applications. The good news is that the process of heating the beans to extract the oil actually destroys the ricin, making the oil itself perfectly safe. The poison is left behind in the mash, the fibrous pulp that remains after the oil has been pressed out. This makes ricin relatively easy to acquire, if one knows what they're doing, which has unfortunately made it a substance of interest for nefarious purposes. Ricin's deadliness depends heavily on how a person is exposed to it. If it is ingested, for example by chewing and swallowing castor beans, the lethal dose is around 20 milligrams per kilogram of body weight. This is equivalent to eating about 8 beans. However, if ricin is inhaled or injected, it becomes far more potent. A dose of just 500 micrograms, an amount that would be barely visible, like a speck of dust, is enough to kill an adult if it gets into the bloodstream. This extreme potency when injected is what has made it a tool for assassins, as it can be delivered with a tiny, almost unnoticeable puncture. Unlike some poisons that act instantly, ricin is a slow killer. It can take 1 to 3 days for the fatal effects to manifest. Once inside a person's cells, ricin goes to work on the ribosomes. Ribosomes are the tiny protein factories in our cells, constantly building the essential proteins our body needs to function. Ricin is incredibly efficient at shutting this process down. It works as an enzyme, moving from ribosome to ribosome and inactivating them. A single molecule of ricin can disable about 1,500 ribosomes every minute. Without the ability to make new proteins, the cells die, leading to massive organ failure and ultimately death. Perhaps the most famous case involving ricin was the assassination of Georgy Markov, a Bulgarian journalist, in London in 1978. While he was waiting for a bus, a stranger jabbed him in the leg with the tip of a modified umbrella. The umbrella was designed to inject a tiny pellet, no bigger than the head of a pin, under his skin. This pellet contained a minuscule amount of ricin, about 1/5 of a milligram. Markov fell ill and died 3 days later. On a more positive note, scientists are now studying ricin's cell-killing ability as a potential way to target and destroy cancer cells, hoping to turn this deadly poison into a life-saving treatment. Our next deadly substance comes from the world of fungi. Amatoxins are a group of poisons found in some of the world's most dangerous mushrooms, most notably the death cap, Amanita phalloides, and the destroying angel, Amanita bisparigera. These mushrooms look quite ordinary, and can be easily mistaken for edible species, which is what makes them so treacherous. A single death cap mushroom contains enough amatoxin to kill an adult, and they are responsible for the vast majority of fatal mushroom poisonings worldwide. The toxin is not destroyed by cooking, freezing, or drying, making any consumption of these mushrooms extremely risky. The potency of amatoxins is significant. The oral lethal dose is estimated to be between 0.1 and 0.2 milligrams per kilogram of body weight. This makes it at least 30 times more deadly than strychnine. The real danger of amatoxin poisoning, however, lies in its delayed symptoms. After someone eats a poisonous mushroom, they may feel perfectly fine for 6 to 24 hours. This delay is deceptive because, during this time, the poison is already at work, silently attacking the body. The first symptoms that appear are usually intense vomiting, abdominal cramps, and diarrhea, which can easily be mistaken for a bad case of the flu or food poisoning. The mechanism of amatoxins is to shut down protein production, similar to ricin, but they do it in a different way. These toxins are complex rings of amino acids that specifically target an enzyme called RNA polymerase II. This enzyme is crucial for creating messenger RNA, the blueprint that cells use to build proteins. By inhibiting this enzyme, amatoxins effectively halt all protein synthesis, leading to widespread cell death. The liver and kidneys are particularly vulnerable because they are the organs that work to filter toxins from the blood. As they try to process the amatoxin, they are destroyed from within. Because of the long delay before symptoms appear, diagnosis often comes too late. By the time a person realizes they are seriously ill, severe and irreversible liver and kidney damage has already occurred. In the United States, many poisoning cases involve immigrants who misidentify the deadly death cap as an edible mushroom that looks similar in their home country. If the poisoning is caught very early, treatments like massive doses of milk thistle extract can sometimes help by blocking the toxin's uptake in liver cells. But for many, the only hope for survival is a liver transplant, a drastic measure that isn't always available in time. Strychnine is a bitter-tasting, white, odorless crystalline powder that comes from the seeds of the strychnine tree, or Strychnos nux vomica, which is native to India and Southeast Asia. For centuries, it has been used as a pesticide, particularly for controlling populations of rats and other pests, due to its high toxicity and fast action. Its bitter taste is a slight deterrent, but when mixed with bait, it becomes a potent and cruel poison. Historically, it has also been a tool for homicide and a common substance used in suicides, though its use has declined as less painful and more effective alternatives have become available. The lethality of strychnine is comparable to that of ingested ricin, with an oral LD50 between 3 and 14 milligrams per kilogram of body weight. A very small amount, less than a quarter of a teaspoon of the pure powder, can be fatal for an adult. Unlike some of the slower-acting toxins we've discussed, strychnine's effects can begin within 15 to 30 minutes of exposure. This rapid onset makes it a particularly terrifying poison, leaving little time for medical intervention. It is absorbed quickly through the mucous membranes and the gastrointestinal tract, spreading throughout the body to its primary target, the central nervous system. Strychnine is a powerful neurotoxin that works by disrupting the normal regulation of nerve signals in the spinal cord. In a healthy nervous system, some nerve signals tell muscles to contract, while others tell them to relax. This balance allows for smooth, controlled movement. Strychnine blocks the relax signal by interfering with the neurotransmitter glycine. As a result, all the muscles in the body receive unstoppable signals to contract simultaneously. This leads to violent, full-body convulsions and seizures. The person remains with die, conscious and cause. And that's in Danson series in extreme pain, as their body arches and contorts uncontrollably. The cause of death from strychnine poisoning is ultimately exhaustion and respiratory failure. The relentless, powerful muscle contractions require a massive amount of oxygen, and the seizures can make it impossible to breathe. The diaphragm, the primary muscle of respiration, becomes locked in a state of contraction. Death can occur in as little as 30 minutes after the first symptoms appear. There is no specific antidote for strychnine. Treatment focuses on managing the symptoms, such as administering muscle relaxants to control the seizures and providing respiratory support, until the body can metabolize and excrete the poison. Cyanide is one of the most famous and rapidly acting poisons in the world. It's not a single substance but a chemical group consisting of a carbon atom triple bonded to a nitrogen atom. This chemical can be found in many forms, including as a gas, hydrogen cyanide, or as a crystal salt, like sodium or potassium cyanide. And, honestly, it's also surprisingly common in nature. Small amounts are present in cigarette smoke and are released when plastics burn. More famously, it is found locked away inside the seeds of many fruits, such as apples, apricots, and peaches, as well as in almonds. It is a powerful and fast-acting poison. Compared to something like botulinum toxin, cyanide is far less potent on a per-milligram basis. The LD50 of sodium cyanide is about 6.4 milligrams per kilogram, which means it is over 6 million times less deadly than botulinum toxin. However, its danger lies in how quickly it works. Cyanide poisoning can be fatal within minutes, depending on the dose and form of exposure. The chemical that exists in fruit seeds is actually amygdalin, which can release hydrogen cyanide when it is digested. Fortunately, you would need to crush and eat a very large number of seeds, around 200 apple seeds for instance, to receive a fatal dose. Cyanide's deadly mechanism targets the very foundation of how our cells produce energy. Every cell in our body contains tiny power plants called mitochondria. Inside the mitochondria, a complex process called cellular respiration uses oxygen to generate the energy molecule ATP, which powers everything we do. Cyanide works by binding to a crucial protein in this process, effectively shutting down the entire assembly line. This prevents cells from being able to use the oxygen that is being delivered to them by the blood. In essence, the body suffocates on a cellular level, even while the person is still breathing. Because cyanide acts so quickly, immediate treatment is critical. Fortunately, effective antidotes do exist. One common treatment involves administering high doses of a chemical called hydroxocobalamin, which is a precursor to vitamin B12. This molecule has a high affinity for cyanide. It effectively pulls the cyanide away from the mitochondria, forming a harmless compound, cyanocobalamin, or vitamin B12, that the body can then safely excrete in the urine. This clever chemical trick can save a person's life if administered swiftly, restoring the cell's ability to use oxygen and produce energy. The 5 poisons we've explored, botulinum toxin, ricin, amatoxins, strychnine, and cyanide, are all deadly, but they achieve their fatal results through remarkably different strategies. Understanding these mechanisms reveals the incredible fragility and complexity of the human body. 2 of the most common targets for these toxins are the nervous system and the basic machinery of our cells. Botulinum toxin and strychnine are both neurotoxins, but they attack the nervous system in opposite ways. Botulinum toxin causes paralysis by blocking signals for muscle contraction, while strychnine causes uncontrollable seizures by blocking signals for muscle relaxation. It's like one cuts the power and the other creates a massive short circuit. On the other hand, ricin, amatoxins, and cyanide all work at the cellular level, disrupting fundamental processes that are essential for life. Ricin and amatoxins both stop protein synthesis, which is like erasing the blueprints and firing all the workers in the body's construction company. Without the ability to build and repair, cells simply fall apart and die. Ricin achieves this by directly disabling the ribosomes, the cellular protein factories. Amatoxins take a different route, blocking the enzyme that creates the instruction manuals, mRNA, that the ribosomes need to do their job. Both paths lead to the same devastating outcome, cellular collapse. Cyanide's strategy is different still. It doesn't stop the construction of proteins, it cuts off the power supply. By binding to a key enzyme in the mitochondria, cyanide prevents cells from using oxygen to generate energy. This is a form of chemical asphyxiation. The blood may be full of oxygen, but the cells are unable to access it, starving them of the energy they need to function. This is why cyanide is so fast-acting. Without energy, critical systems like the brain and heart shut down almost immediately. Each of these poisons has evolved a highly specific and brutally efficient way to disrupt a critical link in the chain of life. The potency of these toxins is another key factor in their danger. Botulinum toxin's lethality is measured in nanograms, a testament to its extreme specificity and efficiency. Ricin and amatoxins are deadly in microgram or milligram amounts. The dose truly makes the poison, and for these substances, the lethal dose is terrifyingly small. This incredible potency is often a result of their function as enzymes, where a single molecule of the toxin can damage thousands of target molecules in the body, creating a cascade of destruction. Studying these mechanisms not only helps us develop antidotes, but also gives us a deeper understanding of our own biology. After learning about such powerful and dangerous substances, it's natural to feel a little uneasy. However, the purpose of this knowledge is not to create fear, but to promote awareness and respect for the natural world. The good news is that exposure to these deadly toxins is extremely rare for the average person. Most cases of poisoning are not random acts of nature, but are linked to specific and often avoidable circumstances. The most important tool we have for staying safe is knowledge, followed by a healthy dose of caution. Being able to recognize and avoid potential dangers is our best defense. For mushroom foragers, the rule is simple and absolute. If you are not 100% certain of a mushroom's identity, do not eat it. Many deadly mushrooms like the deathcap look very similar to edible varieties. Relying on folklore, such as if an animal eats it, it's safe, is a dangerous myth. Always consult with an expert or use multiple reliable field guides before consuming any wild mushroom. Similarly, be aware of poisonous plants that might grow in your area or in your garden, like the castor bean plant. Teaching children not to eat strange berries or seeds is a fundamental safety lesson. When it comes to food safety, proper canning techniques are essential to prevent botulism. The high heat and pressure of modern canning methods are designed to kill Clostridium botulinum spores. You should never eat food from a can that is bulging, leaking, or smells strange, as these can be signs of bacterial contamination and toxin production. While the cyanide in fruit seeds is unlikely to cause harm in small amounts, it's still a good practice to avoid chewing and swallowing them, especially in large quantities. These simple precautions can virtually eliminate the risk of accidental poisoning from these sources. Ultimately, these natural toxins pose a very low risk to our daily lives, but their stories serve as a powerful reminder of the hidden chemistry at play all around us. Science has given us the ability to understand these poisons, identify them, and, in some cases, create life-saving antidotes or even turn them into medicines. By being informed and cautious, we can continue to enjoy and explore the natural world safely. The goal is not to live in fear of what might be lurking in the soil or on a plant, but to move through the world with a deeper appreciation for its complexity and a commitment to making safe, informed choices. Our journey through the world of Earth's deadliest natural poisons reveals a fascinating and sometimes frightening side of biology. From the microscopic bacteria that produce botulinum toxin to the unassuming mushroom that hides amatoxins, nature has engineered substances of incredible power. These toxins are not inherently evil. They are products of evolution, tools developed by organisms for survival, defense, or competition. Their existence underscores the complex web of interactions that defines every ecosystem on our planet. They are a testament to the fact that life is a constant chemical conversation, and sometimes those chemicals are incredibly potent. Understanding these poisons does more than just satisfy our curiosity. It has profound practical implications. This knowledge drives the development of food safety standards that protect us from botulism, and it informs the critical advice that prevents mushroom foragers from making a fatal mistake. It has led to the creation of antidotes that can snatch a victim from the brink of death, and has even opened up new avenues in medicine, where the cell-killing properties of toxins like ricin and botulinum toxin are being repurposed to fight disease and alleviate suffering. Science turns these agents of death into tools for life. The stories of these 5 toxins also highlight the delicate balance of our own biology. They show us how a single, specific molecule can disrupt the intricate systems that keep us alive, whether it's the flow of nerve signals, the production of proteins, or the generation of energy within our cells. By studying what happens when these systems go wrong, we gain a much deeper appreciation for how they work when they are right. These poisons are like keys that unlock the secrets of our own cellular machinery, revealing both our vulnerabilities and our resilience. In the end, the world is not a place to be feared, but to be understood. Nature is filled with both beauty and danger, often intertwined. By arming ourselves with knowledge, we can navigate this world with confidence and respect. We can appreciate the beauty of a flower without eating its poisonous seeds, and we can marvel at the complexity of a fungus while leaving the dangerous ones untouched. Respecting the power of nature means recognizing its ability to both sustain and harm, and using our intelligence to choose the path of safety and discovery.